Hi, welcome back. Today lab I will show you how to build and circuit convert 208 volts AC to DC to light up an 20 mA LED without using transformer. This lab we will apply the understand the meaning of reactance of capacitor and calculate the impedance to limit current passing through the circuit. Here is the circuit diagram we gonna build. Now let analyze the circuit to see what values do we need to calculate. The purpose of this lab is light up the 5 mm LED. We know that the LED need a current of 20 mA. So let calculate the capacitor C1 to limit the current to 20 mA. The 1 ohms is the bleeder resistor for safety. It allows very small current pass through so we can ignore it. The capacitor reactance equal V over I. 208 volts divided by 0.02 amps equal to 10,400 ohms. To calculate the capacitor value, we using this formula. 1 over 2 pi times 60 Hz times 10,400 ohms. The capacitor we need is 0.25 microfarads. The closest capacitor I have is 0.22 microfarads. Let calculate how much currents will pass through 0.22 microfarads capacitor. With 0.22 microfarads capacitor, it limit the current to 17 mA. It is enough to light up the LED. We have the current value, now we can calculate the voltage drop and use that value for verification. The R1 resistor I use 330 ohms resistor. The current is 17 mA. The voltage will be 5.61 volts. Here is the diagram with all components we need. 1.22 microfarads capacitor. 1 ohms resistor. 1 330 ohms resistor. 4 1N 4007 diodes. 1 5 mm LED. And here is how it look on the breadboard. Let go and test it out. Here you can see the input is L1 and L2, we got 211 volts AC. Let release the E-stop to see if the LED will light up or get fried. The LED is light up. It proves my calculation of the capacitor is correct. Let do some measurement at couple points across the circuit. The input is 211 volts AC. The voltage drop after the capacitor is 7 volts. Now switch the multimeter to DC mode. The voltage before the light and after the resistor is 5.28 volts. So my calculation is 5.61 volts. It close enough, and one more time my calculation is correct. Thank you for watching.